thank you all for coming along today. I really appreciate you all taking the time out of your busy schedules to join us on this webinar. I'm the Commercial Director and Senior Engineer here at Motivated, and soon to be chartered. I've been working with chartered engineers for a long time, and I'm just soon to be chartered. And Martin, do you want to introduce yourself there, mate?
Yeah, sure. I'm one of the consulting engineers or senior engineers at Motivated. Been here about 3.5 years, and recently I've got chartered, so about just under 6 months ago. So learning those ropes, but it's been good. Working on all sorts of things.
And a lot of you might know Joe Bain. He's our other director, and he's obviously a chartered professional engineer, been chartered for a long time. He wanted me to pass on that he could bend your ear for a day and a half on the managing a risk and your duties and health and safety responsibilities of a PCBU. Today, I really like to talk about, I guess the heading there says mechanical equipment design and certification. That can mean a lot of different things to a lot of different people, so I'll try and box it a little bit into specifics. Just a tiny bit of background. I guess Motivated for a long time. As you all know, Greg is joining us today. He started the business and really incorporated the analysis and the calculation-based approach to design principles. So the company is called Motivated Design and Analysis, and I guess since the last 4.5 or so years since we've had chartered professional engineers on board, we've really been able to build a lot of the analysis tools into the certification process, and being able to synergize mechanical design, which is often associated with fit, form, function, CAD drawings, GA models, part drawings, part models, that sort of type of collateral, with then an externally provided certification service, usually done by a third party or somebody else who's not really involved or too close to the design. And that's historically how a lot of things have worked and still work today in some cases. So today, I just want to talk to you really about how we can manage our design risks through the certification process, and incorporating those two quite separate pieces, or they can be quite siloed. I guess the situation I was just describing before can lead to siloed thinking in the design and certification aspect. So I'll just jump through quickly and we'll get going. So quickly on the content today, I'll cover mechanical equipment design and certification, provide some examples of that. I have got quite a few pictures in this presentation, and there's not too many words and not too many slides, so it should be fairly enjoyable. We'll look at, I'll just touch briefly on the PCBU's primary duty of care as per the Health and Safety at Work Act 2015. I won't go into that too long. I think all of us are pretty well aware of what that is and what that does mean. Typical design and certification process with examples. I'll take you through how we do our work and what that means. We'll touch on some of the types of certifications, so design statements versus engineering certificates, and the purpose of those and some of the limitations. And then just quickly what it's not. I'm not really going to talk today about anything to do with the PECBA regulations. That would be pressure equipment, cranes, passenger ropeways. Hazardous substance certification I won't get into too much, but I will touch on where some of our documentation leads to, or anything to do with building codes and PS1s and heavy vehicles. I won't touch on those. Feel free to call me anytime if you want to talk about those things. And then we'll do a quick Q&A session at the end. So what do I mean by mechanical equipment and design examples? So this is just a little bit of a snippet of some of the things that we have done over the last few years. So you've got elements there that are carrying a weight, or you need to support a load, and there's risk associated with the failure. So, for example, there's a coil lifter on the left-hand side. Those things are pretty heavy. The client has designed their little lifting jig, And we've gone along and performed calculations, making sure that it should be okay for a test, done a physical test, and then we're certified. Provided an engineering certificate. Lifting equipment, that's very common, governed by quite a few, governed by some fairly standards. There is the trestles, for example, where you can see the flat racks there being supported by trestles. Those pieces of equipment have been designed and built by somebody else at some point in time. We don't even know. I'm not even sure the customer even knew where they came from. But we've been able to go along and provide them assurance that those pieces of equipment can handle what their intended usage, and develop reasonable grounds for them. And I'll talk through those as we go through. Trailer tanks, for example, they have fluid inside, so there's a fluid motion, and so we're making sure that during the load cases, there's not going to be ruptures occurring at high stress locations. That horizontal cylindrical supervolt tank, you can see that is a well and truly exaggerated displacement plot. They don't actually look like that when they see some load. They are very, very stiff. And of course, the main image there is actually a GeoVert crane lifted work platform. So that's something, a typical sort of larger design and certification project where a client such as GeoVert has an end need, and we start at the compliance pathway development end of the spectrum, and then we build the design requirements around those, and then we also build in other design requirements around fit and form and function, and how the client wants to interact with the piece of equipment, and then working through a kind of rigorous process in that scenario. So PCBUs, managing risk. I forgot to get rid of the silly slide process of these because I hate these little things. So I won't touch on this too much, but the Health and Safety of Work Act 2015, it's fairly broad with its description. It really just says a person conducting a business or undertaking PCBU must ensure, so as far as reasonably practicable, the health and safety of workers and other persons are not at risk by its work. And some of the challenges can come from deciding what is reasonably practicable. What does that actually mean, and what does that mean for your business? There's a link there to the WorkSafe website where they try to explain what they mean, but they don't really provide specifics. And so it's really up to the individual business or entity or PCBU to really decide what level they want to take their risk management. And so this presentation touches on really those businesses' use of managing their risk, through the use of chartered engineers. So quickly, what is a chartered engineer? At this stage, before NBIE change any sort of reform or do any sort of reshuffle of their chartered engineering program, which is still all up in the air at this stage. It's generally a Washington Accord 4-year honours degree, or at least proven knowledge to that level. So people are able to have a diploma or a 3-year degree if they've got the proven knowledge. There's additional peer assessment, and they're deemed to meet quality market competence, subject to disciplinary action and bound by the Code of Ethics. So, for example, the hazardous substance group, who do a lot of their hazardous substance certifications, and this is why I'm touching on the subject, they've decided as a group that they would like to see, or they need to see, a certificate of engineering compliance and from a chartered professional engineer. Now, nowhere in regulation does it actually say that a tank, for example, or a fuel storage tank has to be signed off by a chartered professional engineer. But that group have decided that they will be requesting those because of the extra level of risk management associated with using a chartered professional engineer. Some things are non-negotiable. Cranes, for example, they have to, or mobile work platforms, those sort of things. They have lifting equipment. It's fairly well regulated there, but a lot of things don't necessarily require a chartered engineer. But the purpose there is it's another layer or another level of risk management that businesses can incorporate by using the likes of us or others. So the design and certification process. So it's not complicated, and I don't want to make it more complicated than what it is or should be. It's really just incorporating early stage design requirements and compliance requirements that are going to be that drive areas of the design. And it's building those in right up front. So for example, a lot of our clients now, or some of our clients now, have actually started incorporating our input quite early on, but not right at the start. So what they'll do is they'll have one of their internal engineers or part of their internal team will do a few drawings, a few general assembly drawings, or a few concept sketches, a few ideas. Then they'll send that to Motivated, and they will get us to actually, spend a few hours and provide guidance on what we think they need to be worried about, thinking about, what standards we might want to see as built into their compliance pathway. And then they go away with that information. They go and do a whole block of work on their design. They work with their manufacturing team. They go and work with their customers. They do all of that nitty-gritty design, concepting, finalizing through to sort of a 75% of the way there kind of design, and then they come back to us for compliance and for the actual the certification. The beauty of that is we're usually locked into it, and B, and when we've given them the advice right at the very beginning, that's the advice that carries through, and so we get to it's a streamlined process, and designs get to certification quite quickly, as opposed to what can happen and what we have seen happen where PCBUs or manufacturers or designers do spend a significant amount of time on something, getting it sort of perfect, and then we come along at the very end and it fails some simple tests, or simple analysis, or simple load overload tests, and then it's this rework cycle, which is costly and expensive. So it's really the customers and our clients managing their design risk through third-party support and review, and it's a good collaboration between clients, designers, consulting engineers, and chartered engineers. So you've got there's 4 different roles there that I've highlighted, and each one is quite specific and important, and each of those roles has a responsibility to the parts of work that they do. And part of that whole process that actually everybody is involved with, it's not just consulting engineers, but everybody is involved with, gathering reasonable grounds for what it is they're producing, what it is they're trying to make, what it is they're trying to sell. And we take reasonable grounds fairly seriously here. It comes in many different forms, and I'll definitely I'll run you through some examples. But mainly when, for example, when I personally do work or do engineering work, I'm making sure that my work is cross-examinable. So when I've written down a page of calculations, I'm comfortable that that can go to another engineer and be peer-reviewed. And I'm also confident that could go to another firm, a completely separate firm, and that company could go through it and make sure that they would agree with the assumptions, they would agree with the approach, they would agree with the outcome of the type of work that we're doing. And through the course of all of that, by following that design process, where you've got the certification requirements built in up front, by following that through from the very beginning, issuing a final design statement or engineering certificate actually becomes quite easy, because the work's already been done properly. It's already been done. The reasonable ground is already there. The math CADs are already built up. The analysis is already validated. All that stuff that we should do as designers has been done. And the final certificate is actually one of the easiest parts, because you know, everything is ticked off. I have talked for a bit, and I will get to a Q&A session. So if you're sitting on a question, you'll definitely get your chance. So what does reasonable grounds look like? For example, quickly, these same images again. That piece of jig on the left-hand side there that's lifting up that coil lifter. Reasonable grounds for us. That was going to site, taking measurements of their design. They had come up with something that they thought would work. I think one of their designers had done some calculations, but ultimately wanted us to approve it. So we would go along and take measurements of all the critical load carrying elements. We would come back to the office, we would then run some calculations. We would make sure that it could take an overload test. We always run calculations, even on rudimentary pieces of equipment. We'll always run calculations just to make sure that when we do an overload test, we have a good confidence that nothing's going to fail. You know, the last thing we want to do is take some piece of equipment, overload it, and have that fail and create some sort of other incident that is now you know, adding risk. So we'll always do a little bit of calculation, even if it's you know, even if we are going to ultimately test its strength with an overload test. Reasonable grounds for a tank, for example, in the middle there, you've got a DCD tank. Those are quite difficult to physically test that. They're quite a big tank. They're usually 5, 10, 20,000 litres. You'd be hard pressed to try and replicate some of those tests physically. And so we can use tools, you know, available analysis tools, and we can infer compliance and infer strength with a number of assumptions around how something is assembled, how the welds are done, and we can validate the system or the mechanical equipment that way. The trestles, for example, they were quite interesting. So somebody had made those at some point. The customer had a number of different types and different styles and different section sizes, and basically what it boiled down to was doing some fairly simple calculations on the frames as they are, with 2 times working load limit, and then physically loading them up to that 2 times working load limit. And then we, because we have earthquakes here in Christchurch, and we wanted to check its sideways strength, we did that by calculation. We validated those by calculation. We didn't think it was going to be very practical or safe to try and hook up a large load cell to a forklift and try and, you know, test that physically. There's a number of margins of error there. Somebody could actually accidentally pull the whole thing over by accident and apply far more load. So that would be an unreasonable, unpractical way of testing its sideways ability. But we can do that by calculation fairly easily with some simple assumptions. The particular frames that are actually in that photograph, when I was there standing in the rain for 8 hours watching these be loaded, there was quite a lot of wobbling and sideways motion on those particular frames. And then upon closer inspection, we realized that the RHS had been fabricated on the other way. And so it was using its you know, weak axis for its sideways strength. And so we actually derated those quite a bit because of that. So all of that was documented. We had photos, we had images with dimensions on them, we had inspection notes, we had all the videos, and so all that kind of bundled up as reasonable grounds to provide a certification. The crane lifted work platform on the left-hand side, that followed a very similar path to the likes of the trailer tanks, where a lot of the strength was validated through analysis. And I think there were some rudimentary load tests, but not to 2 times. I think we may have just tested it to 110%. But ultimately, a lot of its strength was validated through calculation and analysis. So, what do we actually issue as an end result of working through this process? We've got 2 types of certifications there. We've got a design statement, and I'll show you what that looks like. It's really a desktop review of a new design. It's really a statement of opinion Each of these is a statement of opinion by a chartered professional engineer based on reasonable grounds that, and I'll show you where that wording comes in, but basically it's a statement of opinion that a design meets the design criteria. And that's established through calculations, analysis, and those types of theoretical methods. It puts a big onus on the company who is manufacturing these elements to make sure that they follow the conditions. So specifically welding, for example, analysis methods for welding or weld analysis is always a little bit of a interesting art, and so we make some assumptions around that, and then we request that appropriate standards are used in the manufacture, and that when people are assembling these things, they are following those rules, because we don't get to see it again. Once we've issued our design statement for a tank, a company can go along and make 1,000 tanks a year, and we wouldn't see one of them, which has more risk associated with it. And so generally the fees go up, and so generally we make sure that there's quite a rigorous block of work there, and it really requires a specific design. So yeah, I'll get to that. But and then engineering certificate and plate. A lot of you might be familiar with these. These are just a particular load plate or a certificate, or it's a certificate and a plate attached to a piece of equipment. It can be new or existing equipment. A physical site visit is involved, physical data capture, condition assessment. WorkSafe are quite keen for engineers to actually go and look at stuff physically, especially if you're signing it off. Have a really good understanding of what it is that's there. We will never certify anything off just photos. We will always go and physically look at these things ourselves. There's quite a few of them. And typical range of fees, 2 to 10K. We have gone lower than that if you've got lots of items that are the same, or very similar. But there is a block of work there per design or per piece of equipment to make sure that it's satisfactory. Limitations with that is that they are just one piece of equipment. There's usually an expiry date attached to it, and it's really limited to one piece of kit.
Stu, I might just jump in and add a couple of points there as well. So just on the names of these two types of certifications, a design statement and an engineering certificate, these aren't necessarily terms that are used universally throughout industries, but they're the terms Motivated used to describe two different types of certification. So just to alleviate if there's any confusion with some of those terms, other companies use terms like design certificate and things like that. So, but we will always use design statement, which pertains only to a theoretical design based off, so references only drawings, and then an engineering certificate and plate pertains only to a physical item. Each one has its own number. It also involves checking the construction of that specific item and the condition, and we might reassess that throughout that item's life based on the expiry and of the certificate, as Stu mentioned. So yeah, main thing is those aren't necessarily universal terms, but they are the terms we use to categorize the different types of certification that we do at Motivated.
Very good, thanks, Martin. I've sort of covered this subject a little bit. So these are sort of design statement type projects, more complex, more load cases, difficult to test, and fairly high risk associated with the equipment, and we will spend quite a bit of time creating quite a good reasonable grounds for those types of projects. This is actually what a design statement looks like. So this is a actual design certificate, design statement, and for an aluminium trailer tank, and it's states conditions there. It says on the top there, as an independent design professional covered by policy of professional indemnity insurance to a minimum value of $5 million, I believe on reasonable grounds that when. And then we have a number of conditions, and then we reference the standards that we've used. We've mentioned fatigue on this particular load, on this particular design statement, and then there are more conditions down the bottom. And it's signed and stamped and dated, and that is linked to a particular drawing number. And this is an example of that drawing. So there's probably about 20 sheets of this drawing, and it actually pertains to how parts of it are assembled, how the welding is done, all of the weld notes are captured, manufacturing details. You know, that drawing set is a complete, you know, manufacturing set that we can link to. And any changes to that down the track, you know, need to be updated and captured, and be peer reviewed, and reviewed by the likes of ourselves to you know, update the certificate. Oh, sorry, update the design statement to capture that. Equipment type projects, you know, these are simpler pieces of equipment, lifting equipment that you can overload quite easily to 2 times. Lifting equipment above the load being lifted, like the lifting beam, or below the load being lifted, such as the coil lifter, or even pieces of equipment that are you know, supporting a load, but haven't necessarily been. There's no real design data for them. You know, somebody just made those at some point in a workshop a long time ago, and just picked some steel that was lying around that looked big enough. Which is quite common in this country, and that's okay some of the time. The engineering certificate, for example, is a bit more specific. So this is a particular beam that we're talking about, how it's loaded. Usually there's a serial number, and there is a, you know, how to use it, the working load limit, and that's also signed and dated. And then that also comes with a plate. So we'll update that plate and with the appropriate details, and then we'll attach that to the piece of equipment. So yeah, a quick recap. You know, building these certification requirements up front really helps to streamline the design process. That crane lifted work platform, you know, there was a lot of references to AS 1418, there was a lot of references to 3990, a lot of references to 4991, basically building up those compliance requirements right up front. The customer, all they really cared about was that it needed to hold about a 12-ton drilling rig, and they wanted to have a walkway around the outside of it. That was sort of their design, fairly simple design requirement. As the CAD model started to, I guess, develop, I'll just jump to that quickly. As the CAD model started to develop for this guy, the client had more and more little things they wanted to tweak to the design as natural and as expected, but largely the requirements of that were driven by you know, a number of standards, even handrail standards and stairways. You know, I think we're all familiar with 1657, or everybody's heard of it in our professions, but you know, that's just a good way to link that in up front, instead of having to check someone else's design of a stairway, which they may never have even heard of that standard or used it for a long time. You know, standards do change. So the designers, so Motivated has got designers, and we also work with external designers, our clients' designers, and you know, it's really working alongside them and incorporating and collaborating between chartered engineers, consulting engineers, designers, and the clients and their customers. Another quick recap: reasonable grounds comes in many different forms, as I've sort of worked through. As long as we have you know, again, it's coming back to that word reasonable. You know, what is reasonable? Well, we see that as being you know, cross-examinable. Other companies or other firms or other engineers in a similar field would agree with our approach. We could put our hand on our heart and say, "Yep, we've done a good job." We can sleep at night. You know, Joe and I often joke, and Martin as well. Some of our senior guys have often joked that at 2 o'clock in the morning we've woken up and quickly grabbed a piece of paper and done some calculations just to recheck something. or make sure that we're on the we haven't something isn't out there that is not safe. And I don't think if you're not doing those sort of things, then and having a fair degree of self-doubt, you really shouldn't be in charge of making sure things are safe. And then I've obviously went through design statements and engineering certificates and what they look like. So that fairly well concludes the webinar, but I just more than happy to open up to the floor. If anybody has any further questions, Mark and I are happy to answer.
So do you issue producer statements, PS1s, PS2s, PS3s, etc.?
Yep. We do those for mechanical elements, or building services type elements, ceilings, partitions, HVAC, seismic bracing, all that sort of stuff. That feeds into building code compliance. And so yes, we'll definitely we issue PS1s, done a number of PS2s on some interesting projects, and then we'll physically go and do the inspections and issue a PS4.
You could look at a PS1 as akin to a design statement, and a PS4 akin to an engineer's certificate.
Okay.
Yep.
So is the stamp you put on documents, is that a motivated stamp or a stamp from somewhere else?
That particular stamp, it's a Chartered Professional Engineer stamp, and
Okay.
it's actually because the certificate really does link back to the engineer who's signed that off. There's a connection there, and a culpability and responsibility. So yeah.
The stamp itself holds no weight, though. It is more the signature.
Yeah.
So for some industries, there are actually WorkSafe design verifiers. So do you have to send some of your stuff through to them? Like pressure vessels, that sort of thing?
Yeah, correct. Yep. So for specific equipment like pressure vessels of a certain pressure rating, cranes where they are powered in more than one direction, even we would normally still do our own design statement for certain aspects of that, but it would then be checked and reviewed by a design verifier, and they would do their part.
Any other questions or anything anybody wants to add?
Stuart, would you be willing to share your presentation with us, just so I can share it to my colleagues who may have been unable to attend?
Yes, I'm sure I can manage that. Yep.
Thank you very much.
No worries. I can forward that around.
Appreciate it.
Yeah, I'd just like to thank you two. It was a well done presentation, and even I learned something.
Yeah, I guess in summary, it's not a very complicated subject, but I think there's a lot of confusion around there, what the different types of certifications, and New Zealand traditionally has had an approach where the chartered engineer, he's a one-man band kind of guy, cruising around, and he's viewing pieces of equipment or winches and cranes and little pieces of load carrying equipment, and kind of certifying them, or simple load tests. And it's sort of like it's quite a appealing sole trader type position for some people. And so I guess at Motivated we have in-house chartered professional engineers, and we're supporting. We're not just working in a particular industry. We're really working with all industry, and we can support from the design compliance side of things. We can support the design, actual design work, but we can really work with we work really well when we work with a designer, an experienced designer who understands how they how they manufacture and understands their customers, but really wants to tick the strength blocks, these strength boxes along the way, and during that process, not just right at the very end, having to modify things or change things because they haven't thought of something, because it's not their area of expertise. Just the other day we had a client who does electrical cabinets, and their engineers had spent about 3 or 4 weeks doing analysis for the crane lifting work case. They wanted to have their graduate engineers, they wanted to provide them with experience, they wanted to give them a bit of a challenging project, so they got their graduate engineers to spend a lot of time doing some analysis, and they got us to validate and review their analysis. And through a 5-minute meeting with them, I said, what about the forklifted load case? Who's got fork pockets when you're carrying it around with a forklift? Have you checked that load case? All of a sudden they're scratching their heads, going, "Oh, we missed that one." And so they spent 4 weeks doing a whole lot of work on other stuff, but have missed a very simple thing that is often and easily overlooked as the simple stuff, right at the very beginning.
So your engineers chartered as mechanical engineers or structural, civil?
Mechanical engineers. Yeah, we dabble with mechanical plant structures, or structures that support mechanical equipment, like an HVAC support system, or a scrubber, or a dust extraction system. We'll do we're happy to look at those limit state codes and do a seismic and wind analysis and validate a structure. Pallet racking is a good one as well. Pallet racking is quite interesting because there's a lot of stuff that comes in from overseas, from China, that's rated quite high. It's quite cheap, so it's appealing. And then it gets to New Zealand, it gets installed, and then structural engineers take one look at it and go, "Nope, these sections don't fit into my handbook, so we're not doing that." And then we get involved with trying to validate and provide PS1s for pallet racking structures, which often utilize complex folds and thin materials. We have done that before and dabbled with that type of equipment, and you have to rely on a little bit of yielding to get things to carry the loads, which is always a bit interesting. But yeah, so yes, we do. Yeah,
I was just going to say, also involved in temporary structures and temporary works from that perspective, but not often building structures for public use. More industrial structures supporting equipment and maintenance or access platforms, but generally not permanent building structures.
Yeah. Cool. Well, no one's got any more questions, so I guess we can bring that to a close. Feel free to email me or call me at any time. I'll send the presentation around, and we can. I'm more than happy to answer any further questions. So, at any time.
Thanks.
Cool.
Okay, thank you.
Thank you both.
Thanks everyone for coming along.
No worries at all. Cheers.
Appreciate it.